Hello, let's do Adventist Sudoku, day 13. If you're not familiar with Adventist Sudoku, definitely check the link in the description to the playlist. You can start at video 1 and see what this is all about. But basically, we're doing a 6x6 Sudoku every day leading up to Christmas. They're all by Kinnison, and this one is called Swirl of Steam. So today we have normal 6x6 rules, and we also have thermometers. So thermometers strictly increase from the bulb end. So if I were to put a 3 here, this has to be strictly bigger than 3. I can't repeat the 3, and I have to be bigger, so I could go to 4, for example, and then I could skip to 6. They don't have to be consecutive. So that's how thermometers work. Definitely give it a try yourself. The link is in the description. I'm going to hit reset so I have the correct time, and I'm going to start now. So for longer thermos especially, it's always good to think about what the possibilities are. So I like to count from the tip. There's a lot of ways to do this, but if you count from the tip, it makes it pretty simple to think about. So I count 6, 5, 4, 3, and now this cell is max 3. So I would put 1, 2, 3 here. Let's ignore the red for now. 2, 3, 4, 3, 4, 5, and then 4, 5, 6. These are the only possible values on this thermo. Now this 3 here does see this cell, so this can't be 3, and this 5 sees over here. That doesn't actually affect these cells at all, but it's good to know. Now we have the same thing going on here, but backwards. So again, 6, 5, 4, 3. This is 1, 2, 3, but can't be a 2. Then we have 2, 3, 4, 3, 4, 5, 4, 5, 6, but this can't be a 4. All right, so now let's think about this a little bit. We could do these, but they're going to have a lot of possibilities. So let's look for what might be limited instead. It might be the interaction between these thermos that we have to consider, or I might just want to pencil them. This can't have a 5 on it at all. This 5 sees the entire thing. So yeah, this one can't have a 2 on it at all. This one can't have a 4, and this one can't have a 3. So that's a little bit interesting. Starting with the 2, 6, 5, 4. So this maxes out at 4. So we would normally do 1, 2, 3, 4, but it can't be a 2 or a 4. And then this would be 2, 3, 4, 5, but it can't be a 2 or a 5. So now that we've removed the minimum digit from this one has to be bigger than 3. So this is only from 4, 5, 6. Okay, so let's keep going here. So 6, 5, 4. So 1, 2, 3, 4, 2, 3, 4, 5. 2 and 5 are gone. And again, because of this 3, 4, now this has to be from 4, 5, 6, but it can't be a 5. Now I have found a 3, 4 pair in this row. So this has to be a 6 and this has to be a 1 because 3 is not possible. I can remove 1 from the base here and 6 from the tip here. All right. So let's take a look at these other ones then, see if we can get something similar going on. So this would be 6, 5, 4. This has to be from 1, 2, 3, 4. Can't be a 3. This would be from 2, 3, 4, 5. It can't be 3 or 4. And this would be from 3, 4, 5, 6, but it can't be a 3. So do we have anything interesting there? Let's just do this one. 6, 5, 4. So 1, 2, 3 can't be 4. 2, 3, 4, 5, but it can't be 3 or 4. That is going to give us the 2, 5 pair. And then this one has to be from 3, 4, 5, 6, but it can't be a 4. So we have this 2, 5 pair, which is going to give us this 1 and this 6, which don't do much to limit these. But now that this is 2 or 3, that's important. Because now this can't be a 2. If this was a 2, this could not be smaller than it. So this is now a 5, which forces this to be bigger, which can only be 6. And I think we have figured it out. Okay, this 2, we have a lot going on in the grid. But this 2 here forces this to be a 1 because it has to be smaller than 2. The only digit that's smaller than 2 is 1. This can't be a 2, which means this can't be a 3. This can't be a 5, which doesn't have too much effect here. But this can't, oh no, it means this can't be a 4 because this now can't be 5 or 6. So it did have an effect. This 3, 4 pair now takes 3 and 4 out of these cells. So this has to be a 1 and this has to be a 6. I have a 3, 4 pair here, which makes this a 5. And I have a 3, 4 pair here, which makes this a 2. All right, now we're doing well. So 6, 2, 3 goes down here. The 6 can only go here. This is a 3, this is a 2. 4, 5, 1 goes down here. The 5 can only go here. And then I need 4 and 1. This 3, 4 pair looks down, making this a 1 and this a 4. The 1 also does that. This column is done. We just need a 2. So now this can't be 2, which means this can't be 3. If this is a 3-4 pair, the bigger one goes higher in the thermo. So that all resolves. I need a 2 and a 5 in this row. They have to go this way because of the 2, 5 here. That's a 4. Let's finish this. That's a 6. I do need a 1 and a 5. And then down here, this box finishes with a 3. And our Santa cell is a 4. Nice. 5-minute solve. Not too bad. How'd you do on this one today? I feel like it was a little bit trickier. It kind of teaches you that it can be extremely helpful to pencil mark the thermos with their actual possibilities, which then exposes how they interact with each other with pairs or triples or things like that. So that was pretty fun. How'd you do? And of course, if you enjoyed this content, then why not leave a like and subscribe?